In our last episode, we discussed the possibility of an imminent supervolcanic eruption at Yellowstone National Park, and I got some criticism for not talking about early warning systems that can be used to predict when one might occur. So today, we're gonna talk about how scientists attempt to predict supervolcano eruptions with a little help from some of the most advanced technology that humans have ever developed. Supervolcanoes are the Earth's superlatives. They produce the largest volcanic eruptions that our planet has ever seen. But the very things that make them so fascinating also make them so difficult to study. Because they are so rare, there are so few of them, and their eruptions are so infrequent that the geologic record is incomplete, and it's hard to learn much about them from studying past blasts. Now, I do want to make it clear that by rare I mean infrequent over the course of geologic time. We're talking hundreds of thousands of years between eruptions. But in human history, which is but a blink of an eye compared to the age of the Earth, supervolcanoes have erupted many times. And these eruptions have had dramatic effects on the world, both where they occurred and far beyond. The most famous supervolcano is probably Yellowstone, the site of 3 supereruptions in the past 2.1 million years. There are others though, like Toba in Indonesia, whose eruption around 74,000 years ago may have nearly wiped out humanity from the planet, or Novarupta in Alaska, which erupted in 1912 and was one of the largest volcanic eruptions of the 20th century. Then there's Mount Vesuvius, the volcano that destroyed the Roman city of Pompeii in 79 AD. Yes, Mount Vesuvius is considered a supervolcano. It just hasn't erupted one in a while. Yellowstone and its supervolcanic brethren are formed by giant magma chambers that lurk beneath the Earth's surface. These magma chambers are so large that if they were laid end to end, they would stretch halfway around the globe. Now, this doesn't mean that every supervolcano will erupt again, but they have in the past, and they very well may in the future. So it would certainly be useful to have some way to tell when one of these volcanoes is preparing to blow. Fortunately, there are a lot of signs that precede supereruptive eruptions, and many of them happen far before the eruption itself. We know that supereruptive eruptions start with smaller eruptions. Magma chambers tend to be filled with so much gas that they need a way to vent it, or they'll explode. Scientists call these small initial eruptions the plumbing phase of the eruption, because they're basically the volcano clearing its pipes. During the plumbing phase, pressure builds within the magma chamber, and scientists try to figure out where exactly the magma is going to break through to the surface. Once the magma finds its weak spot, the main eruption begins. The amount of material ejected during this phase is what determines whether the eruption is classified as a major or supereruptive eruption. So pinpointing when the main eruption will begin is obviously very important. But equally important is knowing when the plumbing phase might start. This could allow scientists to warn people in the surrounding area to evacuate and hopefully prevent massive loss of life. There are all sorts of things that can signal the beginning of a volcanic eruption, including increased earthquake activity, changes in the composition of gases released by the volcano, and even slight changes in the landscape caused by the buildup of pressure. Scientists use all of these clues to build early warning systems for volcanoes that might erupt. But building an early warning system is only half the battle. To issue a warning, you first need to detect a change. And the methods used to monitor volcanoes have to be sensitive enough to pick up on subtle signals amidst the constant noise of background activity. Take earthquakes, for instance. Volcanoes are inherently a little bit seismically active because pressure from the magma chamber makes the surrounding rocks crack and shift. Even background seismic noise can sometimes mask the signal of an approaching eruption. But scientists have found ways to sift through all the noise and pinpoint earthquakes that might signal the beginning of an eruption. A good example is Mount Vesuvius, which has been carefully monitored for decades. In 2012, researchers found that small earthquakes that had been dismissed as background noise actually showed a pattern that preceded the eruption. Since then, they've been able to use the frequency of small earthquakes to forecast future eruptions. Now, I know that you're probably thinking, why didn't they use this to predict the eruption of Mount Vesuvius in 79 AD? And honestly, I don't blame you. But unfortunately, the science wasn't quite there yet. The idea that volcanoes might erupt again isn't new, but the idea that we could predict them is much more recent. For most of recorded history, people simply didn't understand volcanoes well enough to develop a warning system. The good news is that now we do. While it's still too expensive to instrument every volcano on Earth, scientists are constantly improving monitoring systems, and they're learning more about how to interpret the data they gather. New technologies are also helping, like, for instance, GPS. It's made it possible to track the movement of the ground above magma chambers with unprecedented accuracy, which helps scientists keep tabs on underground rumblings. And satellites are doing the same thing from space, like NASA's Earth Observing System, Land, Vegetation, and Ice Sensor, or as I like to call it, ELVIS. ELVIS is designed to measure tiny changes in the height of the Earth's surface, which can indicate the buildup of pressure below. In fact, ELVIS has already helped scientists predict an eruption at Mount St. Helens in Washington state by measuring the inflation of the volcano in the months leading up to the eruption. These are just two of the tools in the modern volcanologist's toolkit. They also use things like thermal imaging cameras to detect changes in temperature and spectroscopy to analyze the chemical composition of fumes coming from vents. All of these tools can be used to identify patterns that precede an eruption and serve as an early warning system. But no matter how good our technology gets, it's impossible to be 100% certain that an eruption won't happen. It's more realistic to describe these systems as eruption forecasting models that provide a probability of an eruption happening within a certain time frame. The higher the probability, the more reason there is to get concerned. Let's take the Mount Vesuvius forecasting model as an example. Mount Vesuvius has been studied extensively, and scientists have found that small earthquakes are generally reliable indicators of an impending eruption. So if the frequency of small earthquakes starts to increase, scientists can give the local authorities a probability for an eruption over the next day, week, or month. Of course, scientists would prefer to give a lower percentage rather than raise the public in a panic. But the more the instruments cluster together and point towards an eruption, the harder it becomes to ignore them. At some point, the risk is high enough that authorities might decide to evacuate the surrounding areas. This is the plan that's currently in place for Vesuvius, and it's based on probabilities calculated from the scientific data gathered by instruments like seismographs. The challenge is that different volcanoes will have different warning signs and require different models to forecast their behavior. What works for Vesuvius may not work for Mount St. Helens or Yellowstone. For instance, there are other phenomena that precede supervolcanic eruptions specifically, that don't necessarily show up in the data used to forecast regular eruptions. One is something called a listeric event. This is when liquid magma intrudes into a crack in the rocks of the volcano. The sudden movement of magma causes an explosion that ejects material from the vent. These events are often the first sign that a supereruption is imminent. Yellowstone experienced several listeric events prior to its last eruption 640 years ago, and the same thing happened at Lake Toba prior to its supereruptive eruption 74,000 years ago. These events are incredibly powerful, and they release huge amounts of energy, so detecting them would obviously be very important. But they're also highly variable. Each listeric event is unique and unpredictable, and no two volcanoes behave exactly alike. This means that any early warning system needs to be flexible enough to accommodate all the possible ways a volcano might behave. Fortunately, scientists are working on it. Researchers at the United States Geological Survey are working on an early warning system for Yellowstone that would take advantage of all available data, including seismic activity, ground deformation, and changes in gas emissions. Right now, their system uses artificial intelligence to sort through the vast amounts of data that would be too much for even the best volcanologists to handle. If the AI detects a change, an alert goes out to emergency services, who would then decide what to do next. It would take about 12 hours for the system to collect enough data to issue a warning, but that's still enough time to get people to safety. Ultimately, no early warning system will ever be perfect. New data and new analysis can always improve existing models, But each year, scientists come closer to being able to predict volcanic eruptions with greater accuracy. Hopefully, this will someday include supervolcanoes too. So what do you think? Do you live near a volcano? Would you evacuate if given a warning? Let us know in the comments below, and be sure to subscribe if you haven't already.